Hey guys, and welcome to another 4th Advanced C++ tutorials. Previously we went over the rather long two-parter about on the topic of expanding C++ with Lua, using Lua as like a configuration file or to take advantage of the flexibility of Lua while making your code operate in C++. And to do that, something we had to learn how to do was manipulate the stack, and we learned quite a bit about other stack operations we can do other than pushing um, and extracting information like we did previously when we were binding the other direction. So now we've got this really special function called call, which allows us to call a Lua function. And so far we've used that basically in two ways. We've used it as our way to execute a script that we've loaded in, and we've used it as our way to treat Lua functions as something we can mess with in C++, if we know the name of the function as a string. So now what we want is, or not what we want, but what we're going to find another use of this call function in the Lua library. And what that's going to be based on is sort of a mixing of the idea of using Lua and C++. Instead of saying, hey, we're using Lua and we're expanding on it using the power of C++, or hey, we're using some of the advanced concepts of C++ and we need a little function of Lua to be called, instead of just interacting by function, we're going to make a full more full-blown object-oriented interaction now. We've had objects that can communicate, but really we've only been communicating via function interfaces. We're going to take it to another level up and make it self-contained objects that are half held in Lua and half held in C++. And you're going to see how we're going to manage that. But the idea here, ultimately, is to be able to handle virtual functions. Let's just think about that for a minute. If I had a class called base type, and it had, we're going to not pretend to come up with interesting uses and just make an abstract case this time. If we had this abstract function here, and we were going to make this type of object available to Lua, what would that look like? What would you have to do in order to make objects that were polymorphic in C++, and you wanted them to be polymorphic for some reason? Maybe you're making a simple task-based processing system, or maybe you are going to make a depth-based system and every object has to be processed in a certain order, or maybe you're making just any kind of system really that would need virtual functions. All those fancy design patterns that require you to use polymorphism. Whatever you're doing in C++ that requires polymorphism, but you want to be able to make the objects in Lua, and you want to be able to make that communication between Lua and C++ dynamic and not stuck to a static, rigid function interface. What we could do is or what we can easily do is take an object and make it so that we can call functions that are based on these objects. So we're really just adding kind of new types to Lua. But what we're talking about now is something that is both going to be actively thought about in C++ and in Lua. In the previous code, we saw a little bit of us calling a C++ function that was then going to call a Lua function that was going to call another C++ function. But this is going to have to do a lot more of that, because what we're talking about here is virtual functions. And if you think about it, a virtual function is a function that says, here's my name of a function. When I get called, I'm going to figure out the definition later. So I know that this function exists, but while I'm writing this code, I don't know how I'm going to define that. Later I'll find out. And maybe the way I want to define it is in a Lua function. I want a Lua function to operate as the virtual function instead of a C++ function. So let's get started on that. Here's how we'll do it. If we make a Lua version of this class, we'll of course have to be able to call the virtual function, and we'll have to define that. So what's the definition of this going to be? Somehow we're going to have to make it so that when this gets called, which leads to this getting called, which is the same as this getting called, I should say, that it's going to be paired up in some way with the correct function in the Lua state. So since it's going to be in the Lua state, we'll probably need to know which state this type is actually from. And we'll add that to the constructor real quick. The Lua type on construction will be told what state this Lua type object is a part of. Now, right here what we're going to do is we're going to say, hey, let's get let's find some sort of way where we can pair this object up with a table. How can we pair this object up with a table? Because if this object can be paired up with a table, then we can have the object half in C++ and half in Lua, like I was saying. The objects of Lua are tables, the objects of C++ are classes. So we have the class half. We need to pair this class up with a table that'll have the other information that we need. So let's actually skip defining this for now and figure out how we're going to implement pairing up a class with an object with a table. What we'll do is we'll return to light user data, but we're going to have to use a new feature that I've only mentioned once, but I haven't actually explained super well yet. So we'll make a function that can construct these objects, a Lua interfaceable function. Now let's say we'll start by constructing this. Let's use a full user data. Lua type p equals Lua type. We've seen how this is done before. It's new user data, which creates a new allocates a new block of space for a Lua type and object, and then it will also push that user data onto the stack so that the full user data is then reversing on the stack now. Let me make the stack comment, and this isn't just something I'm doing for my tutorials, by the way. If you are doing any type of complicated operation on the stack, I recommend writing out what's in the stack over there because it helps you to think things through much more clearly. I've always done it for anything more than simple this function calls this function binding. So we are creating the new user data, and we're going to return that. Now the only thing left we need to do is we need to pair this user data up somehow with a table. So first of all, if we're able to make a new table, that'd be nice. So new table. Can we do that? Yes, you can do that. So we've just made user data table is what the stack looks like. Now we also need some way to pair them up. They're both on the stack. Where can we pair them? We could pair them in the global table. We could say set Lua global set, or set global maybe, set global. That'll work, but we have to pair that up with a name, so someone would have to make that work. That's not an ideal solution. What the best solution is to use the Lua registry. The Lua registry is a special table. I mentioned this before. It exists, but it's hidden from the Lua user. The scripter can't access the registry. The registry is sort of invisible space, and the reason it's invisible to the user, or on the Lua scripts, is because that's where anything that needs to be, any Lua operations that need to be done and made accessible to the C++ can be done, but there's no way to really interface that with the script itself. It's just sort of a space where things that need to be connected in some abstract way to the C++ can be connected. So let's use that. Lua set table will be the function we need, and we're going to use the state, and then Lua registry index is the name of the index. That will create a pairing between the user data and the table in the registry. Okay? The problem is, we have a couple problems here. Our first problem is because we used set, the user data has been lost. So let's try let's try copying the user data first. Is there a copy function? Check. Yep, there's a copy function. So we're going to copy from hold on. Here's something we're going to have to look up real quick. Lua. Well, you know what? Better solution. Alright, so there's a way to copy. I know there is. There's a way to copy this user data so that it's like this. But this isn't even a final solution because it'll turn out to be a problem with this. So making this work isn't actually worth a while. But for now, let's pretend like this is how we can do this. We can make a copy of the user data. Not actually a copy of the user data, but a copy of the reference to the user data. We pair up that user data with the table in the registry. Now, what we can do, since they're paired up, is we can do, when we're in this function, we can access that pairing and get the table out. So we'll just do something like Lua get table s Lua registry index, right? That makes sense. So all we have to do to get the right table now is to put the user data right here, right? There's only one small issue with that. How do we get to that user data? While we're here, we don't have any information about what this user data, what user data is paired up with this class. It's a weird property of the interaction between C++ and Lua, and the thing that makes full user data hard to use, because Lua can have this full user data, right? But that's more than just a pointer to the object. If you have a pointer to it, all you can use are light user data. To have the user data, you actually have to have it in a certain context from the Lua. If I'm just executing this and I don't know where I came from, right? I'm just executing this because maybe C++ code is executing. There's not been any Lua going on, and this is an entry point into the Lua scripts. So what's going to happen? It's going to say, can I please, get to this pairing? But it won't actually find this pairing because this is only has access to the light user data. This knows where the address this is, but it doesn't know how to ask for this user data, the full user data, to get put on the stack. There's no way for it to put the full user data on the stack. It can only put a light user data on the stack. More importantly, a light user data pointing to the same thing as a full user data is not the same. They're not equivalent to each other, and that's where the real issue is. So, to solve this, what we'll do is we're going to have to, instead of trying to copy this right here, actually, we're going to put a light user data version right there. So we'll call this user data pointer. And that's not too hard to do. All we have to do is Lua push light user data SP. Alright, so now the light user data and the table are paired up with each other. So later when we have the pointer again, we'll be able to get what we need by pushing the light user data, which is this. Now this and P are the same thing at some point. Whenever this and P are the same thing, then the table that was created here will be available here. Now we've got the table. All we have to do is call a function. So let's do push string s. We'll call this func. So now we have table func. Then we're going to do Lua get table s -2, and we'll get function func. Then we can call it, and we're done. So this should be able, and also like the previous time when we were using the call function, and any time that you're not just making a Lua format function but you're messing with the stack in C itself, you need to make sure that you finish with the stack in the same state as when you started, except for maybe arguments or something. But anyway, this will call a function called func inside this table, which is paired up with this user data. Does that make sense? If we connected those dots, if this function called func paired up inside this table, paired up with this user data. Now, how is that table going to be paired up with that user data going to have that function? Well, we paired up that table and that user data, actually that pointer earlier, and now what we're going to do is we're going to make some way for the user to also provide the correct function. How are we going to do that? We can do it this way. Int Lua set func Lua state s return 0. So we'll make a new function that takes in all user data. New user data s size of Lua type. Alright, so we have the user data. Now we will push the light user data because as before, although we have the user data on the, whoops, shouldn't be new user data, it should be to user data. So we start with the user data on the stack, right? And we are just going to get the pointer to it. Now we have to push the light version of the same user data. Since whatever we gave to Lua, whatever Lua is manipulating is supposed to be a full user data, we have to use the pointer to make it into a light user data. Then we're going to get Lua registry, always remembering that we paired the light user data to the table inside the registry. So now we've got the table, and we can say Lua set table s -2, but now we need to figure out how to get our function right here. This is where we need to get the function so that it'll fit. How do we get the function there? Well, the function's got to be passed in, so we're actually going to need the function right there. And but we have to have the pointer there so we can get the table. So what are we going to do once we've got the table to get the function where it needs to go? What we can do is we can take the table and insert it one layer down. We can move it down one. Lua insert. Here's another simple stack manipulation. It takes whatever is on the top and moves it to whatever index you tell it to. So now it will look something like this. Lua table and function have switched spots, and there we go. Now you call Lua set table, and it will pair up this function with something inside the table. Now we have to decide what to set it to, and we'll just say let's set it to Lua push string s. What is it supposed to be? Func, right? That's what it's got to be so that it matches the string up here. Alright, and we're almost done now. We've got the table, the function, and func. Now we actually have to insert one more time so that we can get everything in the correct order. User data, table, func, function. And we end up with the user data and a table. Because after we set the table, we'll actually have to use a -3 there. After we set the variable func to function that it was passed into this C++ function, we'll be done. So one more time through this function, since it's a bit complicated. We've got a user data and a function passed in. Whoops, this shouldn't be size of, this should be 1. Oops. Alright, so this function is provided with a user data and a function on the stack. We take the first thing, the user data, get that pointer so that we can turn it into a light user data. Then we use the registry to convert the light user data into the table paired up with that light user data. Then we use insert to move the function over 1, because we want the table out of the way so we can get the function and whatever we're setting it to at the front. Now the way set works is the first thing on the top is the value, and the second thing is the key. So this is the key, this is the function, right? Or the value. So we inserted that once, then when we push the string on, we've got that. We just have to insert that in one so that it's in the correct order. Then we can say Lua set table -3, because this would be the -3rd. That's the table we want to use. And so these two will get popped off, and inside that table the func string is paired up with whatever function was originally passed. This lets us set the func whenever we want to. Now that's, let's see how far we've gotten into this, first of all. 20 minutes. Alright, so that's a good start. We're going to continue working on this in the next video. See you later.